represents our center of gravity. Now, the center of gravity is very important. Later on, when you all do your analysis, everything, the applied force is all focused on the center of gravity. However, the x over here, this is the axis of interest. Okay, that is the axis you're interested in. However, we have a shift of our center of gravity by a distance d. Okay. When that's the case, the the moment of inertia m, or the mass moment of inertia, is equal to Ig plus by md squared. Okay. Where we have Ig is the mass moment of inertia, right, about the body's mass center. And then m represents the mass of the body. And then finally, d represents the perpendicular distance between the parallel axis. Okay. Now, yes. So the center of gravity, rather than be on z axis over here, it moved to z prime. So that's why the shift. Say that again. Yeah, so it's going to be rotating at the instance where z is parallel. It can, for this case, there's no rotation yet at that time. Can you like hold your horses? Okay, when you go further, you can see what. Okay. Yes, your question. Wait, I do examples, then you know why you care. For now, okay. And that's where I'm going to show you now. Why do we care? A very good question. It can be answered in a very rude way, but we can't. It's physics. Here we go. I hope I can get into a quick example. I'm going to do this quick. Okay. Now, this table will be provided in your exam. Okay. You all have this table. Okay. I'm not ignoring your question. Okay. I'm not ignoring your question. I have to do you an example, then you appreciate. Okay. Because my English not very good to explain. Okay. Wait, when I do the example, you will see the light. Okay. But don't walk too close to the light. You're still young. Now, I want you to watch this. Okay. You have your I. So this is a sphere. I, Z, Z, I, Y, Y, I, Z, Z, X, Y, Z. This is 2, 5 mr squared. So this is your x-axis, y-axis, z-axis. Okay. Now, you can see the same for all shapes. Okay. Now the thing is this. Can you all see the IZ prime? Yes or no? Now this Z prime, you cannot use IZ plus by MD squared. You cannot use the Z prime in this formula. Are we clear? Okay. Likewise, this is our O, okay. These are all okay. You cannot use these formulas. Okay, you cannot use this formula for IZ plus by MD squared. You cannot use that. Are we clear? You can only use what? IZZ, IYY, or IXX, IYY. Then you can use the what? MD squared. Okay? Why I say that? I made that same mistake before. I don't want you all to make the same mistake. Okay? Now let me quickly do one example. And this is not difficult, by the way. Okay, this is very easy. The most difficult was what? Can you remember? Vibration. Okay, now let's look at this example now. Okay, let's look at this example. Okay, let's look at this example. Okay, so let me get the question. Then you will appreciate why. Okay. The slender rod have a weight of 3 pound-feet. Determine the moment of inertia of the assembly about an axis perpendicular to the page, passing from point where? From point A. Right? Okay. So I'm going to call this vertical rod. And I'm going to call this horizontal rod. Okay. So the part that we're interested, right? The part that we're interested that the axis go into the screen. Okay, go into it. So you write down here member. The member over here, you have your V rod and you have your H rod. From here, the first thing we calculate is the mass. Okay, some people are like, oh, Eugene, not again. We have to calculate what? We have to calculate mass, okay? So the mass is in slug. Okay, so remember what I told you? One slug is equal to what? 32.2 pounds. Okay, so we have our vertical rod. So the mass is equal to what? So it's 3 times 3 because the vertical rod, the length is 3. Right? Then we have to divide by what? 32.2. So 3 times 3 divided by 32.2. 0.28. Look. Horizontal rod is also the length multiplied by the 3 pound-feet is by the weight, and then you divide by 32.2 again. So they're the same, 0.28. Now, the next thing that we're going to calculate is the IG. So for this case, for the vertical rod, we have a rod like this, and the point A is at the top. Okay. So which formula do we use? Right. So we go over here. We look at the rod. Right. It's a slender rod. And it happened to be what? It happened to be, you can use either IX prime or what? IY prime. So the answer is 1/3 ml squared. You can see down here, 1/3 ml squared. So over here, you use 1/3 ml squared. So this will be equal to 1/3 times by the mass, which is equal to 0.28. Length is 3 squared. Okay, so this will be equal to 1/3 times by 0.28 times 3 is equal to 0.84. Okay, the units over here will be slug feet squared. Now, H rod is not so straightforward now. Okay. So if you look at the horizontal rod, the horizontal rod is over here, right? And the point of interest is A, which is this axis over here. But we know the distance from here to here is equal to what? 2 feet. Yes or no? Right? So when that's the case, we know how to get IG for the horizontal rod. So we go to the horizontal rod. We go to the previous page again. Now we have to use what? Hey, Eugene, come on. Now we have to use IXX. Hey, I want to write. I don't want to rotate. We have to use what? IXX. Right? IXX is what? 1/12 ml squared. Okay, so this is equal to 1/12. However, the axis has been shifted, yes or no? Right? The axis is not exactly at the center of gravity over here, but it's at where? At A. Point A is your point of interest. So now you have to plus md squared. So now this will become 1/12 multiplied by 0.28 multiplied by the length, which is equal to 3 squared, plus by the mass of 0.28 multiplied by the distance of 2 feet. So squared also. Okay, so this will be equal to 1/12 times by 0.28 times by 3 times by 3 plus by 0.28 times by 2 times by 2 is equal to 1.33. Okay, 1.33. So therefore, I is equal to 0.84 plus by 1.33. Okay, so this will be equal to 0.84 plus by 1.33 is equal to 2.17 slug feet squared. Yes. 1/12. So initial for the first one, remember, point A is at the top, yes or no? At the edge. If you go to the table, that is also at your X prime or Y prime. It's not at your center of gravity. It's been shifted. Okay? Okay. Right? So if I were to draw this in 2D, isn't it the same like this? At this point. At this point over here is 1/3 ml squared. That's why. Okay? Right. I have to stop here. I want to see what trouble I get into. I'll see you all tomorrow. Okay?